welcome to CEC lectures. I am Dr. Preeti Jagmani from Department of Computer Science, Aryabhat College, University of Delhi. So, in our previous lectures, we were looking at the kinds of buses which are available and how these data transfers are taking place in case in the situation where the data is being transferred from a disk drive to the computer system. So, the data transfer on a bus are carried out by special electronic processors. These are known as controllers, and our today's topic is about the disk attachments and disk scheduling. So, these controllers are actually related to these attachments, we can say. So, basically there are two type of these special electronic processors which are there to transfer the data on a bus. These controllers are of two types. One is the host controller, which is available at the computer end of the bus, and another one is the disk controller, which is built into each of the disk drive, we can say. And computers can access the disk storage in two ways. One is via input output ports or the host attached storage, we can say, which is common in all of our small systems which are non-networked systems. And another idea of computer accessing disk storage is via a remote host in a distributed file system, or we can say simply we can say on a network, and this is also referred to as network attached storage. So, we have one is host attached storage and another one is the network attached storage. So, these two attachments we are going to take up here. So, first let us say host attached storage. So, this is the storage which is attached through local input output ports, and these ports uses several technologies. What technologies we have already talked about, a bus architecture called ATA or the SATA architecture. The typical desktop PCs use an input output bus architecture, which is either known as IDE or it can use ATA technology. These two architectures supports a maximum of 2 drives per input output bus. So, each and every input output bus can be connected to maximum of 2 drives. Similarly, as we have the architecture which is ATA, we have serial ATA which is commonly known as SATA. This is a similar protocol that has a simplified cabling here. So, host attached storage are going to access the data through local input output ports, and they use the technologies like IDE, ATA or SATA. Coming to the second part, which is the network attached storage. A network attached storage is commonly known as NAS. That is a device which is a special purpose storage system that is accessed remotely over a data network. When I am talking about network attached storage, that means a network scenario is being considered here. So, the client access the networks attached storage via remote procedure calls, which are more commonly known as RPCs. So, with the help of RPCs, the client machines are going to access the storage which is available on the network, which is not available on their local machine. Would have been on their local machine, host attached storage would have worked, but in case of the storage which or the data which is to be taken from the network, they need to use RPCs, which is remote procedure call. These are basically kind of we can say call in order to do this particular functioning and we have interfaces such as network file system NFS, or for Unix system we have for NFS is for Unix systems. For Windows machines we have CIFS. So, with these interfaces, these RPCs can be kind of we can say implemented, and client can access the data which is available on the storage which is attached to the network, and these remote procedure calls, which are RPCs, are carried via either TCP or UDP over an IP network. This IP network is nothing but usually the same local area network that carries all the data traffic to the clients. So, we can say it's more easy, or it is more relevant, relatable to think of this network attached storage NAS as simply the another storage access protocol. The only difference is the storage is not available on the local machine, it is available somewhere else, but it is actually a protocol in order to access the storage mechanism. So, here you can see this on the figure. We have, there is a network which is generally it is a LAN, it could be WAN also. So, we have different clients which are going to kind of, we can say, access the network attached storage, which is NAS, available on the next side of the figure. So, these clients are going to access NAS and there is a network which is the LAN in between. So, it is, we can say, it is a kind of protocol, simple protocol in which the storage attached is not on the client side, but on the different side. So, network attached storage provides a convenient way for all the computers, for all the clients which are connected on a LAN to share a pool of storage with the same ease of naming and access which is being enjoyed with the local host attached storage, because naming conventions or naming mechanism is very important here. So, the local host attached storage that ease of naming and access can also be enjoyed in the case of NAS. However, your NAS we can say is little less efficient and have lower performances than direct attached storage options or the host storage options, which is a very we can say obvious thing, because the data is being fetched from the host machine or the data is being fetched from the network machine, another machine which is available on the network is going to give you a difference in terms of efficiency as well as in terms of power also. The another drawback which is attached with the input output operations are specifically with NAS is that they consume bandwidth on the data network also, because the data is being transferred from one particular place to another. It is going to consume bandwidth obviously, which is on the data network or which is of the data network, and hence it is going to increase the latency of network communication, because it is going to take some time. And this kind of problems are actually, we can say, more acute or more critical in case of large installation, large client server installation, where the communication between the server and client competes for the bandwidth with the communication among servers and the storage devices. So, there are two types of communication. One is the communication between client and the server, and another one is the communication between server and the storage devices, and both the set of communication is actually competing for the bandwidth. So, then in that situation it is going to we can say increase the latency of the network communication, because now there is one more competition is there for bandwidth. So, this was actually the idea of how this storage access is going to happen on the we can say local machine, also on the network machine. Now, with all this understanding, or with all this platform being built for our operating system concepts related to disk scheduling, my next topic here is about scheduling the disk. Now, what is actually disk scheduling and how this can be done? Let us try to see. So, the disk scheduling, or let us say for let me recall the agenda of the operating system which we have started in the our earlier lectures. So, all the hardware has to be used very efficiently, and that was one of the prime agenda of the operating system, that it has to use, or it has to ensure the efficient use of hardware. Now, hardware, when we talk about, also includes disk drive, and when we talk about disk drives, ensuring this responsibility of being used efficiently actually boils down to having the fast access time and large disk bandwidth. That means, when we talk about disk drives are to be used efficiently, we are actually talking about having some fast access time and large disk bandwidth, where the my total time of transfer, the data transfer is sum total of the transfer time as well as for the positioning time. Well, the positioning time is comprising of the seek time as well as the rotational latency. This we have already seen in our previous lecture, where the seek time is the time for the disk arm to move to the move to the heads of the cylinder containing the desired sector, while the rotational latency is the additional time for the disk to rotate to the desired sector to the disk head. Now, within this we have disk bandwidth, which is total number of bytes transfer divided by total number of time between the first request service and the completion of the last transfer. So, that is what this disk bandwidth is being calculated, which is the total number of bytes transferred divided by total time between the first request for the service and completion of the last transfer. Both the access time and the bandwidth can be improved by managing the order in which the disk input output requests are serviced. So, I repeat this line here: the access time as well as the bandwidth can be improved if we are able to manage the order in which the disk input output requests are being serviced. So, whenever a process, because this line or this statement is going to we can say build the bottom line for the need of disk scheduling. Whenever a process needs input output to or from the disk, how it is going to happen? It is going to issue a system call to the operating system, and what all information is wrapped in this system call. There are many pieces of information. So, this request specifies what all information. One, whether this operation is input or output, because only disk access has been requested, it has not been kind of mentioned that whether it is input or output. So, within that system call, detailed system call, this has to be mentioned. Then what the disk address for, what is the disk address for the transfer, what is the memory address for the transfer, what is the number of sectors to be transferred, and all these information has to be we can say has to be issued or has to be there within the system call, and that system call is something which a process is going to issue when a disk access is required. So, if the desired disk drive and the controller are available, the request can be serviced immediately, but if the disk drive or the controller is busy and any new request for the service comes up, it is going to be placed in the queue of pending request for that particular drive. So, if the drive and controller are free, immediately the service can be we can say fulfilled. If they are not free, then there is a device queue that we have seen in our early lectures. So, this that process which is going to request the drive or controller for the service will be placed in the queue of pending request for that disk drives. So, in case of a multi-programming system, when we talk about this queue may often have several pending requests. There are many processes which are lying in the queue of that disk drive, in order to get services. Now, the the dilemma for the operating system here is to choose which pending request is to be serviced next, and this is what actually is all about disk scheduling. So, in a multi-programming system, when there is a disk queue having many of the processes which are waiting for the service of which are waiting for the service of that particular disk drive, operating system has to choose which pending request is going to be serviced next, and this is what is actually we can say disk scheduling. It is also known as input output scheduling. This scheduling is a mechanism which is we can say taken up by the operating system in order to schedule the input output request arriving for the disk. So, let us say I am having in a disk queue I am having A, B, C, D and X, Y, Z. These are the processes, these are the requests basically, not the processes. Now, which particular request, whether it is A or whether it is C or whether it is X or Y or Z, which particular request is going to be serviced first, that all is all about disk scheduling, and it is also known as input output scheduling. Now, what is the importance of disk scheduling? Do we really need to have the disk scheduling here in our in our systems? So, yes, we can say the disk scheduling is very, very important, because there are multiple input output requests which are there. Only one can be served at a time by any of the disk controller. Also, it is it involves the resources as in we need a minimum movement of disk, efficiency has to be faster, access time has to be faster, and the resource which is kept busy is that disk drive. So, we want the optimum utilization of that resource with the minimum movement. So, efficiency has to be there, minimum movement has to be there, access time has to be very, very fast. That these are all we can say are the desirable agendas, and hence yes, we can say that your disk scheduling or the process of scheduling the disk is actually important. Also, one point here is, as compared to physical memory, or generally even if we can say, our hard drives are one of the slowest part of the computer system, and that that is the fact which we all are aware. So, then if it is the slowest part of the computer system, one of the slowest part of the computer system, that needs to be accessed in an efficient manner, and hence it increases the we can say importance of the disk scheduling. Also, we have seen couple of terminologies like seek time, which is time taken to locate the disk arm to the specific track. Another, rotational latency, time taken by the desired sector of disk to rotate into the required position. All these two times, seek time and the rotational latency, both should be we can say minimum. Then apart from that, we have the time to transfer the data, that is the transfer time. This transfer time actually depends on rotating speed of the disk and number of bytes to be transferred, and formula we have seen in our previous lecture. So, now what are we looking for? We are looking for minimum seek time, we are looking for minimum rotational latency, we are looking for minimum transfer time. So, all these time quantums should be minimum. And when we talk about the term disk access time, this disk access time is actually a sum total of your seek time, rotational latency and transfer time. That is the total time which includes the transfer time as well as the positioning time, total time which is there in order to access a particular disk or in order to fulfill a disk request. So, that is what my disk access time is, seek time plus rotational latency plus transfer time. So, disk being the slow, one of the slowest part, has to be used efficiently, that we have seen already, and this disk access time has to be we can say as little as possible, because we want to do the access faster, and hence the scheduling is actually very important. So, when we talk about scheduling, there are some scheduling algorithms like first come first served scheduling. We have shortest seek time first, then we have look, CLOOK and many other. So, we will be taking these scheduling algorithms one by one. First of all, let us take FCFS scheduling, which as the name indicates is the first come first serve. This is one of the simplest in order to implement, although it is intrinsically fair, but it generally does not provide the fastest service. Now, for example, in order to understand this FCFS scheduling, we need to understand a disk queue with the request for input output to blocks on the cylinders. So, the cylinder numbers are here given in the disk queue, which are 98, 183, 37 followed by 122, 14, 124, 65 and 7. So, now the first come first serve scheduling says access the request as and when it comes up or in the order in which it is coming. So, the request which is coming first will be accessed first, and hence it is the simplest FCFS scheduling. Let us see how it actually happening. So, here we have a queue in which the requests of the cylinder numbers 98, 183, 37 and so on are there. Then we have our head position. The position of the head is actually at 53. My head is starting at 53. Now, head is at 53 and there is a request which is coming up for the number 98, and that is the first request which has come up. The head goes to 98 and this you can witness in the figure with the help of the arrow starting from 53 to 98. Then after 98, 183 number being cylinder number is being requested. The head goes to 183, after that comes back to 37, then again goes to 122, then again comes back to 14, then to 124, then to 65 and then to 67. So, actually what is happening, as and when the request is coming or the order in which the request is coming, it is being we can say serviced, and hence the first come first serve scheduling. Now, in order to have a detailed understanding of this FCFS scheduling, let us see how much we can say transfer is being happening here. So, total the transfer which I am talking about as transfer is actually the head movement. So, if you can see in this whole queue, the total head movement is of 640 cylinders, and you can witness a kind of we can say very abrupt or wild swing from 122 to 14 and then again coming back to 124. Now, don't you think so that while kind of fulfilling this request, if 122 and 124 requests are being we can say serviced together, then it is going to essentially save a lot of head movement. Yes, it is going to save a lot of head movement, because now there is a wild swing of 122 going back to 14, then coming whole throughout to 124 as well, and that is the problem with this schedule. Even if the request for the cylinder number 37 and 14 could be serviced together, either before this 122, 124 pair or maybe after this pair of 122 and 124, the total head movement can be decreased substantially and the performance would be improved, because with larger head movement it is going to be kind of we can say more of a disk access time. Disk access time is increasing with each and every movement of the head. Now, with this, let us try to understand what are the advantages or what are the disadvantages as far as this FCFS scheduling is concerned. So, the advantages here are every request is getting a fair chance. There are kind of no chances of starvation, or here we can say no chances of indefinite postponement, and this may happen in some other scheduling techniques which we will be covering next. And it is one of the kind of simplest to implement, first come first serve. We need a queue data structure to implement that. Now coming to the disadvantages, so the disadvantages says it is not going to, or this FCFS scheduling is not going to try to optimize the seek time. Seek time, as I have told you with this example, would have been better than when 122 and 124 are being serviced together, or 37 and 24 are being serviced together, then there would have been an optimization of the seek time. But unfortunately, your FCFS does not have any scope for the optimization of seek time, and hence it may not provide the best possible service in terms of total head movements. So, this was all about the first come first scheduling, FCFS scheduling, which comes under the disk scheduling techniques. And in this lecture, we have seen what actually the disk scheduling is, why this disk scheduling is important, what are the controls related to the disk access. We have seen two of them in detail, and we have also after the establishing the importance of disk scheduling techniques, we have also seen one of the techniques of disk scheduling, which is first come first serve. We understood that with the help of an example along with its advantages and disadvantages. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed it. I will see you in the next lecture. Till then, goodbye, take care.